In order to begin writing programs that process vast amounts of data and that model more complex concepts than we've been able to so far, we need to talk about sequences. A sequence is an abstract idea that should feel pretty familiar. It's this idea that we can have effectively one value listed after another value, after another value, after another value. So we can have many values that are related to one another and bundled together in what we would call a composite value. And each of those items within the composite is going to be ordered relative to others in it. So there will be one that's at the 0th index, at the 1 index, at the 2 index. And we've actually seen some sequences before when you've worked with strings. So let's get into it and talk about what a sequence actually is. We think of these as an abstract data type, and we'll see other abstract data types as well that have different properties from a sequence. But what's going to be the common idea of an abstract data type that is a sequence is the items within the sequence are going to be ordered and they're going to be 0 indexed, meaning we're going to start counting the first item is going to have index 0, and we'll be able to access that item through the subscription notation with the square brackets at index 0. And you've used this before when working with string values. An abstract data type tells you roughly what you can expect in terms of the structuring or the data structure that you're working with. And we'll see that there are some other properties that are inherent in abstract data types as well. It tells us what we can do with one of these. If we have a sequence and we know that we're working with a sequence of values, that gives us some sense of its capabilities. So we'll see that there are many types of sequences that we might work with. As I mentioned, you've already worked with strings, and that's a sequence of characters. Some others that are in Python include a tuple, and we looked at this very briefly in the previous video, but a tuple is a fixed size set of ordered values that can be different types if you want. We're going to look at tuples that have all the same type, but you've got more flexibility with a tuple. You could have a string and a float and an int if you wanted, but we're going to look at some simpler tuples that are just made up of, say, 3 ints or 2 floats or 4 bools. All right? The idea of a tuple is that it's fixed in size, and we'll see that you can't actually change tuples after you create them. You can only create new tuples. Lists are different from tuples, but they're still a sequence. A list, we'll see, is a dynamically sized sequence of values that we can add new items to as our program is running. We can also remove items from it or change items in it. And so this will differentiate list from tuples and strings, which are what we call immutable. We can't change them after we create them. A list is mutable, it's dynamic, meaning we can change it. And we'll see that a list is really going to be sort of a broad, multi-purpose tool that we're going to use in a lot of different scenarios when working with data and programs generally. This is perhaps the most useful and most broadly used data type you'll see in programming. We'll look at one other type of sequence that's built into the Python language, and it's also handy. It's the idea of a range, which is a sequence of integers that are spaced out at intervals between some starting point and some ending point. We'll look at that all in the course of the next lessons ahead. Let's start with tuples, which we've already briefly introduced. So when we specify a tuple type, we're going to need to import the type tuple from typing. And this is something we haven't needed to do with some of the primitive built-in types, such as stir and bool. When we're working with tuples and lists and some other complex data types, we're going to see that we need to import these types from a special place in the Python library. And this will allow us to specify new types of tuples in our program. So let's go ahead and take a look at how we might do that. So I've set up an example here, which is a sequences.py example, and I'm going to go ahead and import from the typing library. We're going to import tuple. Okay, so T-U-P-L-E. It's kind of a funny little word. And once we've imported this type, we can make use of it in our program. The way that we specify a tuple type is as shown on this slide, where we see here, we're going to specify, if we wanted to say a type of something of type tuple is going to, my pen doesn't seem to be working. One sec. All right, so the type tuple, we specify the type name, and then because a tuple can be made up, it's a composite type that can be made up of many other types, and we actually have a lot of flexibility here. What we're going to do is within the square brackets of the type, we're saying a tuple of specifically the first values type, the second values type, the third values type, and so on. So we can imagine if we wanted to specify a tuple type that is going to be made up of two float values. And using the type aliasing, which we looked at in the previous lesson, we can put a name like point2d is going to refer to or be an alias of the tuple type where the index 0 is a float and the index 1 is a float, or a sequence of two float values that is fixed in size. This isn't actually setting up any data. We're not creating any new instances of tuple objects here. What we're doing is we're just inventing the type and putting a name to it, right? We're saying point2d is a tuple of two floats. We've seen in examples such as the turtle library where we are making use of colors, and colors we can think of as tuples of three integer values, where the first index 0 would be the red amount between 0 and 255. The second index would be the green amount, and the third index would be the blue amount. So at indices 0, 1, 2 because we're 0 indexed. And we could specify a tuple of three integers by saying tuple and then square brackets int, separated by commas. And that's going to be a type that is aliased by the name color. And using color, notice, is much shorter and much more descriptive than tuple int. Tuple int could be the result of 3 dice rolls or something else. But when we give a type alias like color, it gives a little bit more semantic meaning to the programmers who are looking at and reading the code, and makes it easier to understand. Additionally, if you wanted to write a function that returned a color or took in colors as parameters, notice how much easier it would be to use the type color than having to write tuple int each time you wanted to. So this is where aliases really come in handy. So let's go ahead and try setting up a color alias just like we see here. And I'm going to switch back to VS Code, and I'm going to set up at my top level here. A color is a tuple of 3 int values, right? And what we see is we're inventing a new type. And so maybe we want to write a function that takes in a color and returns a new color that is a little bit brighter. And the way that we make a color brighter is we increase the amount of red, green, and blue in it. So maybe we define a function like brighter, and it takes in a color, which is a tuple of type color, and returns a color as well. And maybe the implementation of this function is return a new tuple that is slightly brighter. Okay. So how would we do that? Well, we can use the input color named a color to set up some variables for, let's say red would be an integer that is a color index 0. And maybe we increase that color by 10%. So we multiply it by 1.1. Right? So this would increase this color by 10%. And the next thing that we're going to do is, and we actually need to convert this back to an int, right? Because this multiplication converted this to a float. So let's convert this back to an int so that we can actually make use of integer values, which are what are expected when we're working with colors in the turtle library. And a green, that's the same idea. And notice that I'm subscripting my a color tuple here with the 0th index, the first index, and now for blue, is a new local variable that will be int a color index 2 multiplied by 1.1. All right. So how do we return a new color tuple? Well, in order to construct a tuple, we need to use what's called tuple literal syntax, which is a pair of parentheses and then your tuple's item values inside of it. So here we would return red, green, blue inside of the parentheses, right? And so now we have this function named brighter. And notice that we're giving it a value of type color, which is a tuple of 3 integers. We could have written tuple int here, but notice how much more tedious this is, how much harder to read this is. So I'm going to change this back, and you shouldn't do this, but I just want to give you a sense that this is exactly what we're saying here. We're writing a function that's a color. It's given a tuple of 3 integers, and it returns a tuple of 3 integers. And notice how much less semantically interesting this is, and how much harder it is to understand what's going on. The only hint that we have that we're expecting a color here is the name of the parameter. But if we use this type alias, which means the exact same thing, these are just two sides of the same coin, we're aliasing a name here, we are able to write a function that looks much more semantically relevant to the problem we're trying to solve. This is a function that you give it a color, it returns you a new color that's slightly brighter. So we could try this out. And what I'm going to do is clear my terminal and begin a new REPL. Right? So let me see if I can get this all on one screen here. So I'm going to start up a Python REPL. And actually, I need to be sure that I am in the right directory. I had changed this just before the demo. So I'm going to start my Python REPL. And I'm going to, from lessons.ls21 sequences, import, and I'm going to import color as well as brighter. These are two names in our global namespace because we defined this function at the top level, and we defined this type color also at the top level. So these are two names that would be bound in globals. This color name would be bound to an object that's the tuple type of these int, and brighter would just be bound to the function definition for it, right? So now we can set up a color. Maybe I do a gray, such as this, whose type is color. That is, let's say a gray has all three of the same color components. So 128, 128, 128. So this would be a color whose red is 128, green is 128, and blue is 128. And if we wanted to investigate and say print gray index 0, well, they're all the same, so this isn't going to be that interesting, but you can see that we can access the items of this sequence directly using the subscription notation. And if we wanted to print out the whole tuple, we see that it's a composite value that is made up of 3 integers. And if we wanted to pass this value to our brighter function, sure enough, I could say, okay, let's call brighter with gray. And notice that it's returned to me a new tuple where each of those components was increased by 10%. Let's try doing this with blue. So a blue color variable would be 0 in the red component, 0 in the green component, and let's say 128 in the blue component. So it's mostly blue. And if we tried brighter blue, oops, I spelled brighter wrong, brighter blue. So that's an example of name resolution failing. When you try and call a function that doesn't exist, you get a name error because the name resolution can't find what you're trying to call. And notice that we've increased that blue component, but we haven't increased any of the red or green. Notice that neither of these functions actually changed if we looked at what is our original blue variable or our original gray variable. We could say lighter gray is a color that is assigned brighter of the gray color that we had previously worked with. It was a tuple. And this would allow us to call that function and store the returned tuple that was created as part of this brighter function. And now lighter gray, if we were to look at it, would be a tuple where each of the components is 140. And gray would still be the original tuple that we had set up. So we didn't actually change anything about our input color. We just created a new tuple using this tuple literal syntax. So tuple types are the first example of a sequence, and we're going to look at, in the very next lesson, lists. And lists are more broadly useful than tuples. Tuples are commonly valuable when you're working with something like a color, where you've got a specific number of components, or a point where you've got a specific number of coordinates, and it has a fixed size. And typically, if you're trying to change something about it, you're okay with recreating a brand new object or a brand new tuple from some input, like we did in the example. You can't change the items of a tuple after a tuple is constructed, but you can reassign a variable to be a new tuple, right? So just to give a quick example of that, let me just finish this up with a lighter gray. We've already initialized this variable and typed it. So lighter gray is brighter of lighter gray, right? So here we're saying we're going to call as the first part of this function call, the brighter function. We're going to give it lighter gray. And then we would jump up to this function. It's going to do its thing, and it's going to return to us a new tuple that is of type color. And that tuple is going to be assigned back to lighter gray. So lighter gray will be rebound to a new tuple object, right? So we do that. And I spelled brighter wrong again. So brighter, there we go. And if we wanted to investigate, well, what is lighter gray now? We see that it's 154, 154, 154. We could increase it again by 10%, and we look at, what is lighter gray now? It's 169, 169, 169. We do it again, and we investigate what is lighter gray. Notice here, as this is a horrible demo because I accidentally reinitialized lighter gray to brighter of our original gray object. So the up button wasn't doing exactly what I thought it was. But the point is, each time we were calling brighter, we were returning a new tuple object, and we can reassign that to some variable back in our main context. So tuples are commonly used for things like colors and fixed size sequences that you just need to very quickly set up a type for and be able to work with in your code.